Hello, my dear children, and welcome. I know, exams are just around the corner and things can feel a little bit stressful, but please, don't you worry. Today, we're going to tackle the atoms and molecules chapter together, and I promise you it's so much simpler than it looks. By the end of this, you're gonna feel super confident. So, let's get started, shall we?
You know, so many of you tell me, "Sir, chemistry is so difficult." But I really don't see it that way. Just think about it like making a delicious cup of chai. You need the right amount of everything, right? The sugar, the tea leaves, the milk, it has to be in the perfect proportion. Well, chemistry is exactly the same. It's all about following the right recipe. So just relax, take a deep breath, and let's learn this recipe together.
All right, let's jump right in. The entire world of chemistry, everything we're going to learn is built on two very simple golden rules. We call them the laws of chemical combination. If you can just understand these two simple ideas, I'm telling you, the rest of the chapter will just click. It'll all make sense.
So our first golden rule is called the law of conservation of mass. It sounds complicated, but it's not. It just means that whatever you start with, you have to end with. Let's go back to our chai. The total weight of the water, milk, sugar, and tea leaves before you boil it is exactly, and I mean exactly, the same as the weight of the chai you pour into your cup. Nothing just disappears, and nothing new appears out of thin air. It just changes form. That's it.
And you know, scientists proved this with a really clever and simple experiment, just like the one in your textbook. They took two different chemicals, put them in a flask that was completely sealed, and weighed it. Then they tilted the flask, mixed everything up, and let the reaction happen inside. And guess what happened when they weighed it again? The weight was exactly the same, not a single milligram of difference. This proved it. Mass is always conserved. See? Simple, right?
Okay, let's get to our second golden rule. This one says that any pure chemical compound, it always has a fixed recipe. It's always made the same way, by mass. So it doesn't matter if you take water from the Ganga River or from your RO filter at home or water that falls as rain. The recipe for water is always the same.
For instance, look at water. The ratio of the mass of hydrogen to the mass of oxygen is always 1:8. Always! It's like a rule that can never be broken. And it's the same for everything else, like ammonia. For ammonia, the ratio of nitrogen to hydrogen is always 14:3. Every single compound has its own unique, fixed recipe. This is the law of constant proportions.
So these two rules made scientists scratch their heads. They thought, okay, why? Why is mass always saved, and why are the proportions always fixed? The answer came from a truly brilliant chemist. His name was John Dalton, and he came up with a theory that explained everything perfectly.
And here he is, the man himself, John Dalton. And you know, he came from a very poor family. He actually started teaching when he was just 12 years old. His atomic theory was a massive turning point for all of chemistry. It gave us the why behind those two golden rules we just talked about.
Now, this slide here is super important for your exam, so listen very carefully. Dalton's theory has 6 main points. He said everything is made of tiny particles called atoms. And here's the best part. He said atoms cannot be created or destroyed. See, that perfectly explains the law of conservation of mass. Then, he said atoms combine in fixed, simple ratios to make compounds, and that, my children, explains the law of constant proportions. See how his amazing theory explains both of our golden rules?
Okay, so now we know the rules of the game, and we know the theory behind them. Now, let's learn to speak the language of chemistry. We're going to find out what atoms and molecules really are, and then, the fun part, we'll learn how to write their formulas. And trust me, it's way easier than you think.
So first, what is an atom? Just imagine a huge, beautiful building. What is it made of? Bricks, right? Thousands and thousands of single bricks. An atom is just like one of those bricks. It's the smallest possible building block of everything in the universe. Your notebook, this screen, even you.
Now the thing is, atoms are a bit shy. They usually don't like to be alone. They prefer to join up with other atoms and form little groups. These groups, where you have 2 or more atoms stuck together by a chemical bond, are called molecules. For example, a water molecule, well, that's just a little group of 2 hydrogen atoms bonded to 1 oxygen atom.
All right, now for the part that I know some of you find a bit tricky, writing chemical formulas. But I'm going to teach you a simple little method. It's like a magic trick that makes it so easy. Are you ready to learn this trick?
So, the secret behind this magic trick is a word called valency. Don't let the name scare you. Valency is just the combining power of an atom. The easiest way to think about it is like this. Valency is the number of arms an atom has to hold on to other atoms. Some atoms have one arm, some have two, some have three, and so on.
Your textbook has that funny octopus example, but let's use our arms idea with a real chemical. Think of the element carbon. Carbon has 4 arms. Its valency is 4. Now think of hydrogen. Hydrogen only has 1 arm. So, to make a stable molecule where all the arms are holding hands, how many hydrogens do you need for 1 carbon? 4, right. 1 for each of carbon's 4 arms. And what do you get? CH4, which is methane gas. It's all just about making sure all the arms are busy.
And here is the magic trick itself, the Criss-Cross method. It is so simple, you'll love it. Step 1, write the symbols of the elements. Step 2, write their valency, their number of arms, on top. And Step 3, just crisscross the numbers and write them down at the bottom. So for aluminum with a valency of 3 and oxygen with a valency of 2, you just crisscross them and poof, you get Al2O3. It's that easy, really.
Now, of course, to use this amazing trick, you do need to remember the valencies for some of the common elements. This table shows you the most important ones, but please don't panic and try to learn it all in one night. Just keep this table handy when you practice, and I promise, after a little while, you will just remember them naturally.
Learning the theory is great, but real confidence, that comes from solving a proper exam question, doesn't it? So come on, let's take a question straight from your textbook and solve it together right now. You will see just how easy this is.
Okay, here's the question. It tells us the weights of all the starting ingredients, which we call the reactants, and it gives us the weights of everything that was made in the end, the products. And it asks us to prove that this whole thing follows our first golden rule, the law of conservation of mass. So, how do we do it?
It's just simple addition. That's all. First, let's add up the mass of the reactants. So 5.3 grams plus 6.0 grams, that gives us 11.3 grams. Okay, now let's add up the mass of all the products. 8.2 plus 2.2 plus 0.9, and what does that give us? 11.3 grams. Look at that. The total mass before is exactly equal to the total mass after. Arre wah! The law is proven and you get full marks. Fantastic.
So, before we go, let's have a super quick recap of what we learned today. We learned the 2 golden rules. Mass is always saved, and the proportions in a compound are always fixed. We learned that atoms are the tiny building blocks of everything, and they join together to form molecules. And finally, we learned that super easy crisscross trick to write chemical formulas using valency.
And I want to tell you all something very important. This subject is not about being some kind of genius. It's just about understanding the logic. And every single one of you is completely capable of mastering this. All it takes is just a little bit of practice and a little bit of confidence in yourself. Don't ever be scared of any subject. You all have the potential to do wonders.
So, all the very best with your preparation. Revise this well, practice some questions, and please remember, if you ever have any doubts, your favorite tutor is always here to help you out. Go on now and do your absolute best.